students, welcome to our science program. Today we'll start talking about Unit 2, Lesson 1, which is talking about electric current. In this lesson, we will study some physical properties of electric current, like electric current intensity and potential difference and electric resistance. So, let's start. Unit 2, Lesson 1. The physical properties of electric current. Okay, so what's meant by electric current? Let's see. The electric current is the flow of negative charges or electrons in a conducting substance or metal wire. So, if we have a metal wire or a conductor and negative charges or electrons flowing inside this conductor, we have electric current. So, electric current is flow of electrons in a metal wire. Okay. Electric current intensity is a physical property or first physical property in our lesson. What's meant by electric current intensity? Let's see. Definition. It's quantity of electric charges flowing through cross-section of a conductor in 1 second. So, the electric current intensity means quantity of electric charges that flowing in 1 second or unit of time. Okay, what is the device that is used to measure the electric current intensity? We can measure electric current intensity by device called a meter. So, a meter is the device that is used to measure electric current intensity. Okay. The measuring unit is ampere. The measuring unit of electric current intensity is ampere. And mathematical relation is electric current intensity equal quantity of electric charges over time. Quantity of electric charges over time. And time should be in seconds. Okay. Let's simplify it. Here we have the rule. Electric current intensity, which its symbol is I, equal quantity of electric charge over time. So, the measuring units, quantity of electric charges is measured by coulomb, measured by measuring unit called coulomb. And time is measured in seconds, and electric current intensity, its unit is ampere. Okay, if we want to calculate electric current intensity, so quantity over time. If we want to measure the time, quantity over intensity. And if we want to measure quantity of electric charges, intensity multiplying time. Okay, let's have the definition of ampere. Ampere is current intensity when quantity of one coulomb is passing through cross-section of a conductor in 1 second. So, when the quantity is 1 coulomb and the time is 1 second, so electric current intensity is 1 ampere. Okay, let's have a problem. 5,400 coulomb pass through conductor in 5 minutes. Here we have the quantity of charges, which is 5,400 coulomb, and the time is 5 minutes. Calculate the current intensity. Okay, here the time in minutes, and we should use it in seconds. So, the answer is time in seconds, 5 minutes, times 60 equal 300 seconds. So, we convert first time from minutes to seconds. Then, electric current intensity, quantity of charge over time. So, the quantity is 5,400 over 300 seconds. The answer is 18 ampere. Don't forget to write the rule, the answer, and the measuring unit. Okay. A meter is connected in the electric circuit in series. the connection of a meter is series connection so that it measure current intensity. So again, to measure electric current intensity, we use a device called a meter, and its connection is series connection. Okay, another physical quantity which is electric potential. Okay, here we have a conductor. It has high electric potential or large amount of charges. And another one which has low electric potential or low amount of charges. Okay, if we connect these two conductors, we can observe that electric charges flowing from high potential to low potential. Electric charge flew from high potential to low potential. So, what's meant by electric potential? It's the state of electric conductor, its condition or state of electric conductor, which determines the transfer of electricity to the conductor or from it when it connected to another conductor. Don't forget, electric charges are flowing from the conductor which has high potential to the other one which has low potential until they become equal. Until they become equal. When two charged conductors touch, they have different potentials. Electric charges flows from conductor with high electric potential to conductor of low electric potential. Potential difference. What's meant by potential difference? It's the work done to transfer quantity of electric charges between the two ends of a conductor. If we have a conductor, at one end we have high potential and in the other end we have low potential, electric charges move from high to low. This difference is called potential difference and makes work to transfer the quantity of charges. So, potential difference equal work over quantity. Again, potential difference equal work over quantity. Okay, let's simplify it. We have here rule. Let's see. V is potential difference, W is work done, and Q is quantity of a charge. This is the rule. So, we have units. The measuring unit of potential difference, which its symbol is V, the unit is volt. And the unit of work is joule. And of course, unit of quantity of a charge is coulomb. So again, measuring unit of potential difference, volt, work done, joule, quantity of a charge, coulomb. So, we have here another term, volt unit of potential difference. If the potential difference between two poles of a conductor where 1 joule is done, work of 1 joule is done, to transfer quantity of a charge is 1 coulomb. So, when the quantity of a charges is 1 coulomb and work done is 1 joule, so potential difference is 1 volt. Volt is the measuring unit of electric potential or potential difference. Okay, electromotive force, another physical quantity. Electromotive force. What's meant by electromotive force? It's the potential difference between the two poles of battery. Potential difference between the two poles of battery is called and its symbol is EMF. EMF means electromotive force, which is the potential difference between the two poles of battery. Okay. Measuring potential difference. The voltmeter is a device that is used to measure potential difference and electromotive force. Don't forget, to measure electric current intensity, we use a device called a meter. And to measure potential difference and electromotive force, which is force of battery, we use a device called voltmeter. And its symbol is circle, inside it letter V. So voltmeter again is the device that is used to measure potential difference and electromotive force. Okay. Voltmeter is connected in circuit in parallel connection. Why? To prevent the current from passing through voltmeter. Of course, to protect it from damage. So, voltmeter is connected in parallel connection. Why? To measure potential difference in the circuit without allowing electric current to pass inside it. Why? To protect it from damage. So here, voltmeter is used to measure also EMF. EMF is electromotive force of the battery. Voltmeter is used to measure potential difference across the lamp. Electric resistance. The third physical quantity in our lesson is electric resistance. So first, what's meant by electric resistance? Okay, when electrons are passing in a conductor, they found some kind of obstruction from the material of the wire. So this obstruction is called electric resistance. So what's meant by electric resistance? It's the obstruction to the flow of the current in the electric circuit. Again, electric resistance is obstruction to flow the current in a wire or electric circuit. Okay, it's measured by device called ohm meter. Device called ohm meter. Again, electric current intensity. Its device is called ammeter. Potential difference voltmeter. Electric resistance ohm meter. Okay, and of course the measuring unit is called ohm. Called ohm. That discovered by the scientist George Simon Ohm. Okay. Definition of ohm. Ohm is resistance of a conductor to the flow of current of 1 ampere, where the potential difference is 1 volt. So, when electric current intensity in a conductor is 1 ampere and potential difference is 1 volt, so electric resistance is 1 ohm. This is the definition of ohm. Okay, resistance has 2 types. What are? Number 1, constant resistance. Constant resistance and variable resistance. Variable resistance means it can be changed, and constant resistance, it has constant value. So constant resistance may be 1 ohm, 2 ohm, 5 ohm, but variable resistance, we can control the value of its resistance. Okay, let's study the variable resistance. Variable resistance is known as sliding rheostat. We have a device called sliding rheostat that we use to change resistance in the electric circuit. So it can be changed to control the value of current intensity and potential difference in the circuit. By changing electric resistance, we can control electric current intensity and potential difference in the circuit. Let's see. The components of variable resistance or rheostat. This is the rheostat or variable resistance. It consists of metal wire, very long metal wire of high resistance, wrapped around cylinder made of insulator such as porcelain. So here we have a cylinder made by insulator material like porcelain and very long metal wire of high resistance turned around it. This is the metal wire coil and porcelain cylinder. Okay, copper sheet that can slide over the whole length of wire called slider. Here we have this part is called slider that we can move it across the copper wire Why? To change the resistance. And this is the metal wire porcelain cylinder. Okay, how the variable resistance or rheostat operates. Let's see the idea. Changing the length of wire change resistance. By changing the length of the wire, resistance changes. Okay? So, increasing the length of the wire, increasing resistance, and decreasing current intensity. There is inverse proportional between them. Increasing length of the wire, increasing resistance, and decreasing current intensity. So, we can use rheostat or variable resistance to control current intensity. Decreasing the length of the wire, of course, decreases the resistance and increases current intensity. Okay, finally we have Ohm's law. Let's see. Here we have electric circuit consists of a meter to measure electric current intensity and voltmeter to measure potential difference and variable resistance and battery. Form an electric circuit as in the figure. Close the circuit and change the position of slider or changing the resistance. Record the value of I, which is current intensity, and the potential difference, which is V. So, by changing resistance, value of electric current intensity and potential difference change and record them. Let's see. Change the resistance and take the value of intensity and potential difference several times. Okay. Current intensity, ampere. Potential difference, V over I. Here we have a ratio between potential difference and electric current intensity. We can find that. Conclusion. The ratio between potential difference and electric current intensity is constant and equal to conductor's resistance. So here, the ratio between potential difference, which is V, and electric current intensity, which is I, is constant. And this constant ratio is resistance or electric resistance. So, sample of resistance is R, and its unit is ohm. Don't forget, we measure it by device called ohm meter. Ohm's law. Current intensity is directly proportional to the potential difference across the ends of a conductor at constant temperature. This form is called Ohm's law. We observe that increasing intensity, increasing potential, decreasing intensity, decreasing potential. So the relation between them is directly proportional, and this is Ohm's law. Current intensity is directly proportional to potential difference. So here we have the rule. R, which is electric resistance, equal potential difference over electric current intensity. Okay, what about units? Resistance, electric resistance, its measuring unit is ohm. Potential difference, which is V, its unit is volt. And of course, electric current intensity, its unit is ampere. So again, what's meant by ohm? Ohm is electric resistance. Ohm is electric resistance when potential difference is 1 volt and current intensity is 1 ampere. Okay. Here we have definitions. Ohm. Ohm is resistance of a conductor when current intensity is 1 ampere and potential difference is 1 volt. In this case, we have electric resistance equal 1 ohm. Ampere, we will define it according to Ohm's law. Ampere is current intensity in a conductor where resistance is 1 ohm and potential difference is 1 volt. When potential difference is 1 volt and electric resistance is 1 ohm, so electric current intensity is 1 ampere. Volt. We will define volt according to Ohm's law. Volt is potential difference. Volt is potential difference between the two poles of a conductor when electric resistance is 1 ohm and current intensity is 1 ampere. All of these definitions are related to Ohm's law. R equals V over I. Mathematical representation of Ohm's law. I equal V over R, or R equals V over I, the same. Here we can see the graph is increasing, or it means the relation between them is directly proportional. Increasing intensity, increasing potential difference. Okay, let's have solved problem. If the intensity of a current is 20 ampere, pass through heater where its potential difference is 220 volts. Calculate the heater resistance. Okay, here we want to calculate electric resistance. Okay, let's see the rule. Electric resistance equal potential difference over electric current intensity. Here, electric resistance equals potential difference 200 volt, 220 volt, and current intensity is 20 ampere. So the answer is 11 ohm. 11 ohm. Ohm is the measuring unit of electric resistance. So don't forget in our problems to write the rule, the calculation, the answer, and the measuring unit. Ohm's law, that is made by the great scientist George Simon Ohm. Ohm's law determines the relation between electric current intensity and potential difference. Okay, let's make a circuit contains voltmeter and ammeter and switch and battery, which volt is 1.5 volt, and nichrome wire, which is resistance. Here we want to change value of electric current intensity and electric potential or potential difference to know the relation between them. We use just one battery. Make the switch on and look carefully. We can see that electric charges flowing across the circuit. First, we measure electric current intensity and measuring potential difference and record the result. First, we connect one battery, then we connect two batteries. Okay, we can observe here electric current intensity is increasing and also potential difference is increasing. Okay, let's use another battery. Here we change batteries or increase number of batteries instead of using rheostat. The same idea. Okay, here we can see electric current intensity is increasing and potential difference is increasing. So here we can find that the relation between electric current intensity and potential difference is directly proportional. This is Ohm's law. It states that electric current intensity is directly proportional to potential difference at constant temperature. Dear students, at the end of our lesson, don't forget the main concepts of electric current and the concepts of electric current intensity and potential difference, and how to calculate Ohm's law. Thank you very much, and till we meet again, goodbye.